Hello everyone, welcome back to this online class. Today we are going to look at numerical solution of ordinary differential equations, and in particular we are going to look at Adams-Bashforth Adams-Moulton method. Now we are given this question, given the tabular values below for the ODE, dy over dx is equals to x squared times 1 plus y, with the step size h is equals to 0.1. So we have the table of x versus the y values. We are asked to use Adams-Bashforth Adams-Moulton Predictor-Corrector method to compute the value of y of 1.4 correct to 4 decimal places. So the good thing about this Adams-Bashforth Adams-Moulton Predictor-Corrector method, of course it is of fourth order method, that you must first of all know the first four functional values. What I mean is that you must know the value of y0, y1, y2, and y3. Those must be given. If they are not given, then you may be asked to find them using either Runge-Kutta method or modified Euler's method or Euler's method or Taylor series method. Now here we have x0, this is x1, this is x2, x3, and here it is x4. So what we don't know is the value of y4. So our task is to find y4, which is the same as y of x4, and this is the same as y of 1.4. We don't know this. So once you know the first four starting values, then use Adams-Bashforth predictor formula to predict the value of y4. Once you have obtained the predicted value, then you use Adams-Moulton corrector formula to correct the value of y4, which you had predicted initially. So let me give you the formula for the predictor and also the corrector methods. So we start with, even before I give you the formula, look at our table. We know that x0 is equals to 1, y0 is equals to 1, and from the ODE, f of xy is equals to x squared into 1 plus y. So number one is the Adams-Bashforth predictor formula. Instead of Adams-Bashforth, we can just abbreviate this as AB to mean Adams-Bashforth. So this is the formula. It is yn plus 4 star, yn plus 4 star is equals to yn plus 3 plus h over 24 into 55 times f of n plus 3 minus 59 times f of n plus 2, then plus 37 f subscript n plus 1 minus 9 f subscript n. This is the predictor formula. That will help you get the value of yn plus 4 star. Now, the corrector formula is that of Adams-Moulton. So you can write number 2 is Adams-Moulton corrector formula. It is given by yn plus 4 is equals to yn plus 3 plus h over 24 into 9 fn plus 4 plus 19 fn plus 3 minus 5 fn plus 2 plus fn plus 1. So we are iterating. You write for n is equals to 0, 1, 2, etc. So the predictor formula will always give you the predicted value of the whatever function or value you are looking for. And then the corrector formula will correct the predicted value. It will help give you the most accurate result. So instead of Adams-Moulton, we can abbreviate this as AM. And so that's why we call this method as ABAM, Predictor-Corrector method. AB means Adams-Bashforth, AM means Adams-Moulton. So for the Adams-Bashforth, you predict. Adams-Moulton, you correct. So now let's go back to our problem. The initial value problem, dy over dx is equals to x squared into 1 plus y. We are going to iterate from n is equals to 0. We start from 0. So you can write here, put n is equals to 0. What are we going to get when n is equals to 0? Let's start with the predictor. That will give us y4 star is equals to y3 plus h over 24 times 55 f3 minus 59 f2 plus 37 f1 minus 9 f0. Take note that when we write fn, it is the same as f of xn yn. When we write fn plus 1, it's the same as f of xn plus 1, comma, yn plus 1, etc. So now, before we find y4 star, first of all, we need to know the value of f0, f1, all the way up to f3. So let's find f0. It is equals to f of x0, y0. That is equals to, look at our definition of f of xy. It is x squared plus 1 plus y. X squared times 1 plus y. So where there is x, I'm going to put x0. And where there is y, I'm going to put y0. So this will be x0 squared into 1 plus y0. And so this equals to our x0. Can go back to the table. Our x0 is 1. And our y0 is also 1. So we replace them here. That is 1 squared times 1 plus 1, which is simply 2. So that's f0. Let's get the value of f1. So similarly, f1 is equals to f of x1, y1, and that is x1 squared, 1 plus y1. x1 you can read from the table, that is 1.1. You square it, then 1 plus our y1. Let us read it from the table. That is 1.2330. 1.2330. 2330. When you press this in your calculator, you need to get 2.702. Go to F2. That should give us f of x2, y2, and that is x2 squared 1 plus y2. Our x2 is 1.2, we square it, and 1 plus our y2, again refer to the table, that is 1.5485. 1.5485. When you press this in your calculator, you need to get 3.669, and we also need F3. That is f of x3, y3, and that is x3 squared into 1 plus y3. x3 is 1.3, you square it, 1 plus y3, we have it again from that table, 1.9789. So this is 1.9789. And when you press this in your calculator, you need to get the value of F3 as 5.036. 0.036. So now that we have found F0, F1, F2, and F3, and we also know H, and we know Y3, we can now be able to find Y4 star. So you can just say here that therefore, our Y4 star, the predicted value of Y4, is equals to Y3, which we got 1.9789 plus H is 0.1 over 24 into 55 F3 5.036 minus 59 F2 3.669 plus 37 F1, which is 2.702, then minus 9 F0, which is 2. Press this in your calculator. You need to get Y4 star is equals to 2.5726. 5726. So this is the predicted value of Y4. So I'll comment on this and you write predicted value of Y4. We need to correct it now using the Adams-Moulton corrector formula. So let's go back to the corrector formula and then put n is equals to 0. Look at the corrector formula, this one. So when you put n is equals to 0, what do we get? That should give us, you can just write here, use Adams-Moulton corrector formula. We are using it to obtain the most accurate solution of Y4 because we have predicted it. Now you have to correct it. So when I put N4, I'm going to get Y4 is equals to Y3 plus H over 24 into, that was 9F4 plus 19F3 minus 5F2 plus F1. Somebody might be wondering why I'm getting F4, F3. I'm substituting N is equals to 0 here, because this is the general form of the corrector formula. So when you put n is equals to 0, you are going to get what I've just written. So now you realize that in the corrector formula, we have F4, which we don't have it here already. So we need to compute it first before we use it. Already we have the value of F1, F2, and F3, as you can see, F1, F2, F3. But I don't know the value of F4, so let me compute F4 first. So write F4, it is equals to F of X4, Y4. But you see, I don't know the value of Y4. What I know is Y4 star. So instead of Y4, let us use the predicted value. So Y4 star. So this should give us, based on our definition of F of XY, it is X squared times 1 plus Y. So instead of X, I'm going to use X4. And instead of Y, I'm going to use Y4 star. So this will be X4 squared times 1 plus Y4 star. And so this equals to our X4 is 1.4. We square this into 1 plus Y4 star. We have found 2.57226. And when you press this in your calculator, you need to get the value of F4 as 7.004. 004. So now we have F4. I also know H and I also know Y3. So we can now be able to find Y4. So you can write here. Therefore, our Y4, the corrected value, is Y3, which was 1.9789 plus 0.1 over 24 into 9 times F4, 7.004, that is a 0.004. Then the next is plus 19 times F3, which we got as 5.036, minus 5 times F2. Let's refer to our F2. That was 3.669. Then we have plus F1, which is 2.702. That's what we have. Press this in your calculator. You need to get the value of Y4, the corrected value, as 2.5751. 2.5751. Correct to 4 decimal places. So this is the value of Y when X is 1.4. So we can comment on this and say that this is the corrected value of Y4. And what it means is that it is the value of Y when X is 1.4. And that's what you are required to find. Remember, if you need to find Y5, you need to perform then another iteration now when N is equals to 1. Do the same things, the same procedure, I mean, to be able to find Y5, if you are asked to do that. But in this question, we are only asked to find Y4, which we have found as 2.5751, correct to 4 decimal places. And also take note that the derivation of the predictor-corrector formulas, you can find them in my PDF notes. So just take some time and go through the notes to understand how we are deriving those predictor-corrector methods, both Adams-Bashforth, Adams-Moulton, and also the Milnes predictor-corrector methods. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Cage. When you go to the YouTube search, type Francis Okage or Prof. Francis Okage, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving numerical solution of ordinary differential equations. Bye-bye.